So let's start the notes 2.2, and we're going to start at the very top. The objective for today is to use the properties of reflections. Let's review what the definition of a reflection is. A reflection is a transformation that outputs a mirror image of a figure. Okay. The line of reflection is the line across which the pre-image is reflected. Okay, so we're going to do a couple of patty paper exercises that are very similar to the ones we've done in the first lesson. Let's look at our notation. For problem 1, we're being asked to reflect line segment AB across line M. So here we have line segment AB, and here we have line M. And we're supposed to label A prime and B prime. So A will be reflected into A prime, and B will be reflected into B prime. So let's go ahead and do it. Let's get our patty paper, or thin paper, anything that you can trace through. And first thing I want to do is draw my line. Okay, and then I want to draw points A and B. And let me connect A and B. Things moved a bit, but it doesn't matter because I'm just connecting these 2 points at this stage. Point A and B. Okay, good. Now I'm going to take my patty paper. I'm going to flip it upside over like this. And I am going to now line up the lines so they are pretty much coincident across the patty paper. That looks pretty good. And now let me use my pencil for this. I'm going to dig in to point A and dig into point B. Again, I'm perfectly fine if they go through the patty paper. That'll be helpful for me. I'm going to draw the line AB. And dig in there as well. And let me label my points A and B. Let's see what we got. Okay, good. That's nice. We can see point A, and we can see point B. And let me just make that a little stronger line over here with my straight edge. And there I go. There is my reflection of, whoops, forgot to put my primes. Don't want to forget that. I'd get points off on my test if I forgot that. Okay, so now I've labeled line segment A prime, B prime. Okay, actually, it really should say this. Okay, there really should be a line segment up there, because if I'm going to reflect a line segment, I'm going to get a line segment. If I reflect a point, I get a point. If I reflect a triangle, I get a triangle. Okay, so whatever I'm reflecting, I'm going to get the same type of object, because remember, reflection is an isometry. I'm going to get a congruent figure. Let me go over to problem number 2. This problem reads, I am supposed to do the reflection of triangle EFG across line little m. And there I've got points E, F, and G connected to make a triangle. I've got line M here. And then when I get the triangle E prime, F prime, G prime, I'm supposed to label it such. So let me go ahead, get another piece of patty paper, and do my construction. So I'm going to first trace my line. Of course, you should be following along with me and doing this in your notes. So let me line things up here. I'm a perfectionist. Okay, let's get that just about right. Okay, good. I've got my line. And now notice point G is right on the line. This is a point right on the line, which we're calling G. And then this is point E over here. And this is point F over here. And now let me draw my lines in my triangle, the line segments which are the sides of the triangle. FG. Whoops, everything slipped. But again, I'm at this point. That's the advantage of starting with your points. You're really just connecting points, even if you lose some of the reference to the original drawing. All you're doing is connecting your points. As long as your points are accurate, the rest of the figure should fall into place nicely. And here, I'm going to now connect these 2 points. There we go. Okay, so I've got triangle EFG traced. I'm now going to flip my patty paper upside down. I'm going to line my line up on the patty paper with the line underneath so that they're just about overlapping. Try to do that as perfectly as I can. I think that's pretty good. Now I'm going to go ahead and I'm going to dig in. So this is point E. Make a really hard point E. I don't care if I go through the patty paper. This is point G, and this is point F. And make them really deep. Make a real indentation on that sheet. And then let me connect with some firm line segments, the sides of the triangle. Okay, 1, 2, and 3. Okay, good. So now let me take this away, and I can see that I have some very nice indentations in the paper. It should be pretty easy for me to complete this. Got this side. Got this side. And I've got this side. And maybe I was a little off on one of those sides just a bit, but you get the idea. Okay, good. And now let me make sure I have my labeling correct. I probably don't need to go back to my patty paper. I think you should be able to see that this point here is going to be point F prime because it is reflecting across the line to point F. But let's just double check with our patty paper. Okay, yeah, that was F, and this is E. And then this is G prime. So this is F prime, this is E prime, and this is G, which is equal to G prime. As we said once before, if a point is on the line of reflection, then it will not change when it's reflected. It will stay in its place. So G is equal to G prime. They are the same point. Maybe there's a little bit of an equality there. Okay, so now let's go ahead. This is the correct illustration. Let's answer some of the questions that we've got below. 3A, and we're supposed to use the figure in problem 2, which is this triangle here. Is the image an isometry of the pre-image? Yes. Okay. Yes. Why? Because length and angles are preserved. And also because reflection is an isometry. Okay, so there's really 2 parts to the answer. Either part would be fine. Reflection is an isometry. And in an isometry, length and angles are preserved. What is the orientation of the pre-image? Let's take a look at the pre-image. EFG. To go from E to F, F to G, and G back to E is clockwise. It's a clockwise movement, so the orientation of the pre-image is clockwise. what is the orientation of the image? That would be what we drew in here, E prime. Oops, did I not put the prime in there? Sorry about that. Okay, that would be E prime to F prime to G prime back to E prime. I think you can see this is a counterclockwise movement. So the orientation of the image is counterclockwise. And we've had this before. In a reflection, is orientation preserved? No. Okay, so that if in figure Z is reflected to figure Z prime, the pre-image and the image do not have the same orientation. Okay? And let's look at question number 5. In a reflection, is point P and P prime ever the same point? When? Well, we've done this a couple of times, and we've done it just now. You can see point G and G prime are the same because they align on the mirror line. So the answer is that in a reflection, is point P and P prime ever the same point? Yes. If point P lies on the line of reflection.